Okay, guys, we're going to work on a proof to prove that segments YZ and XY are proportional with ED and XV. So YZ and XY are going to be purple, and ED, whoops, ED, what? That's not ED, it's VW, my bad, like the car, VW. VW. All right, so our first step in proving that, remember, is always to just jot down our given. And here we can tell that YV is parallel to ZW. And our reason for that is that that's given. We can see those parallel markers on our diagram. All right, the next thing we need to do is we need to determine that these guys are similar. And so we know that angle X will be the same for both triangles. So I'm going to say that angle X is congruent to angle X. That makes sense, doesn't it? Remember, we called that the reflexive property. All right, the next thing we need to do is we need to say that angle XZW, angle XZW is congruent to angle XYV. XYV. Now, how do we know that? Because if these were parallel lines, you know, if our parallel lines here, and we want to know that this angle, no, I'm sorry, it's this angle and this angle, let me erase that other straight mark there. If we want to know that those two angles are congruent, how do we know that? We know that because they're corresponding angles, okay? Same player, different team. Same position, different team. They're corresponding angles. And if you don't remember that, just look a few problems before this for a review of corresponding angles. All right, the next thing we want to do is we want to look at angles keep saying A. All right, we want to know that these two angles are congruent. And again, we know that because they're corresponding angles of these two parallel lines. Okay, XW is the transversal there. So I'm going to say that angle XWZ is congruent to angle XVY. All right, and again, we said that's because they're corresponding angles. Phew, now what do we do? All right, so now what we want to look at is we want to say that, and I'm going to change colors so you can kind of follow along with me here. I want to say that XY corresponds to YZ in the same way that XV corresponds to VW. In other words, I'm just doing top over bottom, left equals right. Now, how can I say that? I can say that because that's the definition of similar triangles. The definition of similar triangles is that they make that proportion. That proportion is equal. Okay. All right. Now I can say that. Wait, do you see what we're going to do next? Let's go with some green. I'm going to say that XY plus YZ equals xz. Okay, what I'm doing is I'm just saying this part here plus this part here equals the whole thing. Okay, and then I can also say, and I'm just kind of sprawl out here a little bit, I can also say that xv plus vw equals xw. So I just did it for this side over here too. I can say that this one plus this one equals this whole thing. Okay, and I can say that from the segment addition postulate. Remember that from a long time ago? The segment addition postulate tells me that I can add those two segments to get the whole one. Segment addition postulate. Let me go ahead and write postulate. All right, so we're doing good so far. All right, so now we're just going to substitute that back into, this. Okay, so I can say that xy, and I'm just going to sprawl into two blocks here, xy plus yz over xz equals, wait a minute, that's not what I'm trying to say here. Hang on just a second, let me erase this. All right, so what I'm going to do here is I am going to substitute, but I'm going to say xy plus yz over the part xy equals xv plus vw over the part xv. Okay, and so all I've done here is substitution. Okay, I just substituted that in. All right, so we're going to cruise on down a little bit more to the next step. And the next step, what I'm going to do is I'm going to kind of separate those ratios out a little bit. So I'm going to do xy over xy plus yz over xy. And that equals xv over xv plus vw over xv. All right, so the addition property tells me that I can separate those out like that. So I'm just going to call that addition. Well, think about this. I know that xy over xy is equal to 1, right? Xy over xy is equal to 1. So I'm left with 1 plus yz over xy over here. And over here, xv over xv is equal to 1. Now, if you'll remember, what I was trying to prove is that yz over xy equals vw over xv. So what do I have to do from this step to get to that step? Well, let's take a look. It's just like when I have a variable that I want to isolate and I want to get him all by himself. So here I want to get yz over xy by itself. So to do that, I'm going to subtract 1 from both sides. And when I do that, when I subtract, I am left with what we were trying to prove. I am left with yz over xy equals vw over xv. So by proving that the different parts are equal and that those parts can be added to form the wholes, I can prove that those two bottom parts are also equal or congruent. Okay, so what I was trying to prove was that this side is congruent to this side. Okay, so that gives you the proof in the steps. What you have to do on your test is just fill in some of these blanks. So study this carefully and then go take on number 37.